Hi. Okay, under the concept of factor formula, so I'm going to show you how to prove the following identities, right? So as you see that this is have a different angle, right? The size of the angle is different. 7, this is 3, this is 3, this is 7, and this is not 6, 4, not 2. So most probably, if this case happen, they have different angle, then the angle is not even. Usually it's involving, or you can see that 7, 3 suddenly become 5. Not even the half of this, right? So it's not, I think it's not involving double angle formula, right? Not involving double angle formula. You see all the odd number here. So then you have, and this angle also different. So I think this will be using the factor formula. So factor formula, you have sine A, you look at here, you have sine some plus sine B, different angle, right? So I'm going to use the sine A plus with sine B, this formula, which will be 2 sine 1 cos. The first one will be A plus B over 2. This one will be A minus B over 2, right? So I think I'm going to use this formula, and this one is given in your examination. So let's look at the denominator. You have cos A plus cos B, right? You are using the formula for cos A plus cos B. So the formula for cos A plus cos B, as you remember, you memorize, you know that it will be 2 cos. You have 2 cos. One will be A plus B over 2. One will be A minus B over 2. So you can looking at the formula sheet. So the formula given, then you know this is the 2 formula that you're going to use. So let's see from the left hand side here, right? From the left hand side here, which is sine 7. You see the process how I carry out the proving. So divided by cos 7 theta plus cos 3 theta. So okay, I'm starting now. So sine A plus sine B, right? So it's this formula, sine A plus sine B. So will be 2 sine cos, right? So I combine them first. 2 sine cos. So for the denominator, cos A plus cos B, you have 2 cos, right? Cos. So A plus B over 2 means 7 plus 3 over 2. 7 theta plus 3 theta over 2. A plus B over 2. And for cos, you have A minus B. A minus B over 2. Same thing here also. A plus B over 2, A minus B over 2, right? I just apply the formula, right? Just apply the formula. And the 2 here you can eliminate, right? 2. And for now you have sine 7 plus 3 over 2, you have 5 theta. Beautiful, right? You see the 5 theta here is what we need here, right? So then your cos 7 minus 3. 4 over 2, 2 theta, right? Let's look at the denominator. You have cos, 7 plus 3 over 2, 5 theta, cos, 7 theta minus 3 theta over 2, 4 theta over 2, you get 2 theta, and this is identical, right? So you can cancel out. Then you have sine over cos, right? Then you're getting tangent 5 theta, which you have already proved this identity is true, right? So this is the where I'm using factor formula in helping me proving an identity. Let's look for another identity which I'm going to prove. Okay, let's continue with these identities that I'm going to prove. So okay, then you have 2, yeah, double angle. You have double angle. It may apply double angle, but as I see why it won't be a double angle, because I see the final product here. Usually if I see 2, I will apply double angle formula. But this case I'm not applying double angle formula because I see there is a combination, there is a compound angle here. Alpha minus beta, right? So if double angle, here will be alpha or here will be beta, but not alpha minus beta. So I think that this will be using the factor formula, right? So you have to do many practice in order for you to can see that what you're going to use to produce this identity here. So now, as I see that this is a cos of A minus cos B, right? So I can apply as cos A minus cos B, this formula. There are 4 formula for factor formula: sin A plus sin B, sin A minus sin B, cos A plus cos B, cos A minus cos B. So in this case, I see there is a cos minus cos, different angle. So I apply cos A minus cos B, which is negative 2 sin A plus B over 2 cos A minus B over 2 is the formula that I consider now, the first formula. So the second one, I look at the denominator, sin A plus sin B, right? So I'm using the formula for sin A plus sin B. This is factor formula. So 2 sin A plus B over 2 cos A minus B over 2, right? Okay. So, sorry, this will be sin. For cos minus cos, you have negative 2 sin. So, alright, now I'm going to starting proving. So for the left hand side, right, left hand side, which is cos 2 beta minus cos 2 alpha divided by sin 2 alpha sin 2 beta, right? So then you have cos A minus cos B, right? Okay, the A now is 2 alpha here, right? So never mind, I just using that formula, right? Cos A minus cos B. So this is your A now. For now, this is your B. So it will become negative 2 sin, right? One will be 2 beta plus with 2 alpha over 2, right? A plus B over 2. Sin A plus B over 2. The other one will be minus. It will be 2 beta minus 2 alpha over 2, right? Okay, so I just using the formula directly. Later only I consider what for sin. This one we have 2 sin cos, right? The factor formula for sin A plus sin B, which is 2 alpha plus with 2 beta over 2, and this will be 2 alpha minus 2 beta over 2, right? Okay, finally I have getting the, for this I have negative 2, 2 beta plus 2 alpha divided by 2. 2 beta divided by 2, 2 alpha also divided by 2, you have beta plus alpha, right? Beta plus alpha. Beta plus alpha also can be write as alpha plus beta. They are the same. And sine, this one, 2 over 2, 2 over 2, you have beta minus alpha, right? After you simplify. And for the denominator, you have 2 sine alpha plus beta. Why? Because 2 alpha over 2, you get alpha. 2 beta over 2, you get beta. So, and for this one, you have cos 2 over 2, then you have alpha minus beta. So finally, you have to do some cancelling where the 2 gone, and the sine, it is, can you see? Alpha plus beta, so you can cancel out. Then you have remaining of negative sine beta minus alpha over with cos alpha minus beta. Right, but the problem now is with this, right? You have alpha minus beta here, right? So you need the sine alpha minus beta. Never have the misconception here that you can multiply the negative inside. It's not multiply, you know. It looks like multiply, it's not. We are applying negative angle. So we need the knowledge for negative angle. So means that it's not multiply. It seems like you multiply the negative inside, but it's actually not that meaning here. But you can think about it. You can think about this is a you can multiply it, but it's actually not, right? So let's see. You have beta minus alpha, right? So you know that sine beta minus alpha is the same as sine. You factor out the negative, you have alpha minus beta, right? We see negative alpha, negative, positive beta, right? So it's negative theta, right? This is like negative theta. So you will have negative, you can take out the negative, become sine alpha minus beta, right? Means sine beta minus alpha, after I convert, is negative sine alpha minus beta. So then I know that the sine beta minus alpha is negative sine alpha minus beta according to negative angle formula. So cos alpha minus beta. Negative, negative, you're getting positive, right? You're getting positive. And exactly, alpha minus beta, sine over cos. Then you will have tangent alpha minus beta. Then you already prove this identity is true, right? So I will give you one more example. Right, let's continue with these examples where you have multiple angle here, right? Multiple angle, multiple type of angle. You have theta, you have 3, you have 5, you have 7. Suddenly become an even 4, 2 theta, right? Different angle, all have different angle. So this one, most probably for this type of proving, you need the knowledge of factor formula, right? So if you see what is the, as you see that sine A plus sine B, if you look at this one, 3 plus theta, if you divide by 2, you will have 2 theta here, right? You have 2 theta here. So if you take 7 plus 5, you will have 12. 12 divided by 2, you have 6 theta. It's not here, but most probably later it can help you to getting this. So you can try 5 plus 3. As you add up the two odd number, all here is 1, 3, 5, 7. All is an odd number. So you add up any two odd number, you divide by 2, you are getting an even number, right? As you know that. So for example, 3 plus 1 you have 4. 5 plus 7 you have 12. 5 plus 3 you have 8. So means that all you are getting an even number. So I think factor formula is the best for this case here. So since all they are sine, so I will using the formula for sine A plus sine B exclusively, because I can't see there is a cos here. So I'm using sine equals to 2 sine A plus B over 2 cos A minus B over 2. Because finally you have cos, can you see that? So it means that it must be using sine, so that you produce a cos sine, right? But now, for now, all is sine, right? So I just try and error. So let's look how I'm proving. I may add up these two, sine theta. So I starting from here, that the left hand side, the sine theta plus with sine 3 theta. I group it as something I want to apply as sine 5 theta plus with sine 7 theta, right? So sine theta, sine 3 theta, I usually will asking students to arrange such that if you want to using the factor form, it's okay if you apply this way, right? So I want to avoid negative angle formula. So sine theta and sine 3 theta is actually, it's the same as sine 3 theta plus sine theta, right? It's the same. So because I want to avoid that when you minus this, you have negative angle, right? But it's okay, right? It's okay. You can also using this, but I prefer okay? I prefer. So I write as 7 theta plus 5 theta. I just interchange these two. So it's the same, right? This is the same. So when I apply formula, I will apply this formula, right? Sine A plus sine B. So which will be 2 sine 3 theta plus theta over 2. A plus B over 2. Sine A plus sine B, right? 2 sine A plus B over 2. And cos 3 theta minus theta over 2, right? Okay, so I apply the factor formula for this. So now, for this, it will be 2. 1 sine, 1 cos. It will be 7 theta plus A plus B over 2. A minus B over 2. Alright. Then you will have here 2 sine 3 plus 1, 4. 4 over 2, 2 theta. Here you have cos 3 minus theta, 3 minus theta, you 2 theta over 2, you have cos theta. So how about this one? You have 2 sine 7 plus 5, 12. 12 over 2, 6 theta, and cos 7 minus 5, 2. 2 theta over 2, so you have theta, right? So Now, easy. You can see that they have common factor, right? They have common factor. So cos 2 cos theta, 2 cos theta. So I taking out the 2 cos theta. But I see that there is a cos theta here, right? So I can say, yes, I can do it. So now, then I have 2 cos theta I taken out. Then I have sine 2 theta plus with sine 6 theta. Right? You can take it out. So now, this is my target now, right? Now, this is my target now. So I rewrite here. I have 2 cos theta. Okay, now consider about this one. 2 theta, sine 2 theta plus sine 6 theta. So you want to apply sine A plus sine B. It's okay if you apply directly 2 plus 6 over 2, 2 theta minus 6 theta over 2. But to get a negative angle there, you need to apply negative angle formula. But I try to avoid, alright? I try to avoid. So I just writing here, before I proving, I write this to be 2 cos theta. And this one will be sine 6 theta, the larger angle put in front here. So sine 2 theta, right? Sine 6 plus sine 2 theta. So I will have sine A. Now this is your A and this is your B, right? So apply this formula again, right? So 2 sine cos. So you have 6 theta plus 2 theta over 2. 8 over 2, 4, right? You can see that. So cos 6 theta minus 2 theta over 2. 4, 6 minus 2, 4, 4 over 2, 2 theta, yes. So now you have 2, 2, 4 cos theta, and this one will become sine 6 plus 2 over 2, 4 theta. For this you have cos 4 theta over 2, 2 theta. If you rearrange this, one becomes 4, the sine 4 theta, the sine 4 theta, cos 2 theta, and cos theta, all you have, right? Finally, you have proof this identity purely by applying factor formula, right? So hope you understand all the proving question. It's just give you an idea of how to proving a identity, right?